Hello college algebra student, this video is still for chapter 5.6 part 5 application of rational functions. So let's do some work problem. So usually rational functions are used to model some average of something or concentration of something. Concentration of drugs in bloodstreams, average cost, average profit. So let's look at one application, which is C of x is a concentration function that model the blood concentration and body concentration in parts of a certain dosage of medication after T hours, and T has to be greater than 10. So that means after 10 hours, what is the concentration? So how does it drop off? So usually after certain hours, then you have less part of that material in your body, right? So this would be modeling that concentration. So notice for rational function, they usually have a end behavior of a horizontal asymptote if the degree is the same or the degree of the numerator is less than the denominator. So look at ours. The degree is 1 in terms of t is degree 1, and the bottom is also degree 1. So they would have a horizontal asymptote. So let's say, what is the concentration at t equal to 10, because it's valid for 10. So this is just plug in, right? So it becomes 7 plus 900, so it's 907 divided by what? 4 times 10 plus 5, so 20.16 ppm. So 20 parts per million. What value does the concentration approach as the time elapses indefinitely? So they're asking for actually end behavior when t is greater than 10 and also approach infinity. What would happen? So we are looking at end behavior that is horizontal asymptote, and because they have the same degree, so horizontal asymptote would be y equal to the ratio of their leading coefficients, which is 0.7 over 4. 0.7 over 4 is 0.175. So the value would it would drop from 20 ppm to 0.175 ppm, and forever when the time approaches infinity. Will the concentration ever decrease to 0? No, right? When t approaches infinity, it's approaches point or y, c approaches 0.175. So it would never reach 0. Will the concentration ever be increasing after t equal to 10? So maybe we go graph it. Okay, so let's write it down. It's 0.7 t. Typically, if it is if you don't have access to calculator, you would have to graph it by hand. So that's why we want to know how to graph things. But we have the graphing calculator, so we just use it. So we would say y equal to what, 0.7t plus 900. Okay, so it's this one, the numerator, divided by 4t plus 5. So let's see. So when t is 10, 10 is here. So we'll see how it goes. Just getting closer to the horizontal asymptote. So it would not be increasing at all. So you say, will the concentration ever be increasing? No, it would be, no, it would decrease. The second example is another concentration. Concentration of drugs T hours after being injected into the bloodstream is 0.7t over t squared plus 70. So in this case, T hour after being injected, so it will be T is greater than 0. You can model this. Find a time when the concentration is at a maximum. So so because you see how in the so this is degree 1 and this is degree 2, you can see the denominator do we have any other, this is a case where there is no vertical asymptote, because when you do t squared plus 70, you can never be 0, right? There's no solution. You have a square, which is time, is always a positive number. It would never be 0. So no solution, so no vertical asymptote. Okay, so it's kind of like a graph that's smooth. Find a time when it is a maximum. So you use a graphing calculator to do. So this is the one that we don't want to do it by hand. 0.70 again, t squared plus 70. Just this away. 0.70. 0.70 divided by t squared plus 70. Now the difficult part of this is you can't even find a graph. So where is it? So this is like a line. So you would need to find out what happens when t is 1. No, like, oh, maybe I'll just use the function f of x. So f of 1. Oh no, this is t. When t is 1, that is like that, right? Very small. So you're not supposed to have an x that is that big. When t is 2, what happened? It's still 0.1. When t is 10, what happened? It's this 0.0 something. So you would know that your y can never be that big. Your y maybe just 0.0, 0.02, the maximum. The lowest would be negative 0.002 also, to see what happens. See, it shows up pretty good now. So because you can see that even at 10, it is like that. So the maximum, you click on it, you can see the maximum. The maximum is y is 0.04183 at 8.4 hour, 0.04183. The maximum at, find the time, 8.4 hour. Time equal to 8.4. The concentration of T is maximum, equal to 0.04. Is that 0.04? Yeah, 0.041. So that's good enough. So that's how you do a work problem. Usually is to find out if what the long-term effect, if you have some concentration, will it ever drop to 0, and also in certain cases where actually a graph does not have vertical asymptote, it might have a maximum. So you use a graph to graph it.